Okay, so today we're going to look at, well, we're going to start chapter 9 for Pre-Cal 40S. This is rational functions. It's outcome R14. There's going to be a lot of graphing in this one. This one's got graphing and analyzing rational functions. So we're going to limit the numbers and the denominators to monomials, binomials, or trinomials. So that means to the power of 3 is going to be the biggest thing. We're not going to have to the power of 4. Okay? All right. So exploring rational functions using transformations. So remember this way back from chapter 1? Remember chapter 1? We did transformations. This is coming back again. So now our new parent function is 1 over x. Do you guys have a clue? Do you know what 1 over x possibly looks like? I believe we looked at this in grade 11. Remember? Okay, so if you can't remember what a graph looks like, the easiest thing to do is to quickly draw a table of values, and I'll start you off with the x values. Pick -2, -1, 0, 1, 2, and fill out what the values are. So you've got -1/2, -1 over 1, -1 over 0, 1 over 1, 1/2. Okay, what do we know about this number right here? Okay, it's undefined. All right. Yeah. So when a number is undefined in a graph, what does that look like on the graph?
It's an asymptote.
That's the asymptote, right? So where does the asymptote actually show up on this graph here? At the right here on the y-axis. Okay, so this is x equals 0. Now, since we can't really see the asymptote when we draw it directly on the axis, so just extend it a little bit beyond the drawn axis there. Okay, let's write out the definition of what a rational function is. So a rational function is a function that is written in the form f of x equals p of x over q of x, where p of x and q of x are polynomials expressions. Okay, and we also have to say that q of x can never be equal to 0. Okay, because then that would give us something that's undefined, and that's actually where our asymptote ends up. So if we were to take these points and graph them, they would be -2, x is -2, and then minus 1/2 right here, -1, and my right here, and then so I'm gonna turn this over so I can draw my asymptotes nicely. Okay, we can also draw in this asymptote right here, and then I can draw in the other side here. So I've got 1 and 1, which is right here. This is 2 and 1/2, and so this is what my graph looks like here. And if I were to graph the points 1/2, I would end up with the reciprocal values, right? So that's a reminder of what that graph looks like. All right, so just a reminder here, x equals 0 is non-permissible, so it creates a vertical asymptote. So when x approaches infinity and y approaches 0, and when x approaches -infinity, y approaches 0. So y equals 0 is the horizontal asymptote. So the curves are going to end up in quadrant 1 and quadrant 3. Now, what would the graph of negative 1 over x look like? So if you were using the transformations from chapter 1, what do you think happens to this graph? It flips in which direction? So all the y values switch, right? So the ones that were positive now become negative. So these end up going here and these end up going here. So now this is what my graph ends up looking like. So it flips in that direction. And then this one here, so I can just use transformations to get a quick sketch of what that is. Okay, helpful if you see it. All right. Now, so the curves are now in quadrant 2 and quadrant 3. Quadrant 4. There's still a vertical asymptote, so you still have your asymptotes in the same place in the x and y axis. Okay? All right. So if we were to look at the next question, it actually talks about same idea as what we were doing in chapter 1. Now we just have a different parent function. So what would be the moves on this? If we were just to think of where is this function f of x going, what does this 3 do to it? It's a vertical stretch, yeah, so that's a vertical stretch by a factor of 3. Okay, and then what does this do? Okay, yeah, horizontal shift left 2. And then this right here is down 1 unit. All right, so what else moves along with it other than just the points of the graph itself? So what else moves along with it? So we had the asymptotes originally at x equals 0 and y equals 0, right? So the asymptotes were here and here. Now where are our asymptotes? They will be moving to left 2 and down 1. So you see this graph right here. This is the graph given to you of 1 over x stretched vertically by a factor of 3, moved left 2 and down 1. Okay, so now your new asymptote is here at -1, at -2 over here. And now if you were to look at this equation, what can you notice, what can you tell me about this equation right here, this part of the equation, and a part of the graph that could be a significant connection that you can make? What's the connection that you could make with this part of the graph right here and something on the graph? So the asymptote. So you've got x plus 2 in the denominator, right? Now we know that x plus 2 can never equal 0, right? Because that would deem this part undefined. So that's going to be an asymptote. So x equals -2 is an asymptote. Okay? Now, because x can never equal -2, what do you notice y can never actually become? We can never make this 0. This can never be 0, so y can never end up being -1 either. because of that. Okay, so there's the connection there between the asymptotes and the equation. All right, so the general equation of the rational function is y equals a over x minus h plus k. So these are the same values that we were using before with our transformations. Now, the vertical stretch by a factor of a, which is followed by the horizontal shift of h units and the vertical shift of k units. So this is x equals h is going to be the vertical asymptote, and y equals k is going to be the horizontal asymptote. So if you just look at the equation, this equation here, and think through that thought process that we just did, then you could logically see what the values of the asymptote are. Okay, so if you were to be asked an explain question or a why question, that would be your response. Make sense? Okay, so using the above graph, explain the behavior of the graph for values of the variable around the non-permissible value. Also explain the end behavior of the graph. So what can you tell me about when x equals -2? As x approaches -2, y becomes, the absolute value of y becomes very large. And what can you tell me about the end behavior as the absolute value of x becomes very large, y approaches -1? Okay. So you want to look at what the graph is doing and where it's going based on the asymptotes it's approaching. Okay.